Birthday yesterday?
Yeah.
Happy belated.
Thanks.
What'd you get, like a new Pokemon or?
Oh, heck yeah. Got all them Pokemans. New lacrosse equipment.
Oh, did you?
No, I don't play lacrosse.
That would have been nice. Okay, so I'm going to go to your class. Okay, in the middle there you see lab, replacement of hydrogen by a metal. Okay, boom. All right. So I'll take you through this in a second, but essentially what you're going to do here is you are going to take a container filled with water and a tube that has a little acid in it and water and a piece of metal at the bottom. And what's going to happen is the acid's going to trickle down through here, encounter the metal, it's going to dissolve the metal, and it's going to produce hydrogen, similar to what you did at the beginning of the year with the acid on the zinc. Remember last time when you blew it up? Okay. But this time we're going to catch the gas and measure it. Okay. So that's essentially what we're doing. So when we catch this gas up here, it's going to be hydrogen gas, but what else is going to be in there? We already covered this.
Metal.
No. That's good. No. No.
Vaporized water.
Water. Water vapor. Remember Dalton's law of partial pressures?
Yeah.
Okay? So I'm just telling you that when you guys took the test on this, a lot of people missed this problem. It was the most missed problem.
Oh, that's kind of a random question, but is it possible for like something inside of a bubble to be so heavy that the bubble doesn't float to the top of the water?
Okay, here's a random answer. Cheese.
What?
Well, if you're going to ask me a random question, I was going to give you a random answer. I was thinking of cheese. Not cheese, the student. I was thinking of actually of like a Colby. Okay. I'd say no. Okay. Yeah, the gas is just going to be less dense than the liquid, so it's gonna rise to the top. I thought that was funny. All right, so that's what we're gonna do. All right, so here's what we're gonna do: is I'll take you through first. We'll just look at the procedure. We'll look at all the equipment, and then we got to talk about calculations because again, you have to do the calculations on your own. There are things you can share tomorrow. There are things you cannot share. I'll be very clear about what you can and can't share. All right. People always take that, and that warning goes in one ear and out the other. And then there's going to be some people that turn in the exact same work, and I'm going to say, you work together, and hopefully it'll only be your first time, and you get half credit. But if it's the second time, then you got a problem. Okay. All right. So this says lab replacement of hydrogen by a metal. So the hydrogen initially is in the solution in the liquid, and the metal is a solid. And the metal is going to go into the solution, replacing the hydrogen, meaning it's going to kick the hydrogen out of the solution, and we're going to catch it and measure it. So in this exercise, hydrogen will be produced when magnesium reacts with hydrochloric acid. The volume of gas generated will be measured, and using the ideal gas law, the moles of hydrogen will be calculated. So just like at the beginning of the year we were saying weighing is counting, then molarity, measuring volume, became counting. Then when it came to gases, we had to use PV equals nRT, right, to count gas particles. So that's what we're going to do. We're going to count how many hydrogens that there were, and that's going to let us figure out the mass of the magnesium. From the balanced equation, the moles and mass of magnesium will be determined and compared with the actual mass used. Okay. Now a couple pointers. First of all, step one, I'm going to give you further instructions about step one tomorrow. The magnesium I get, do you remember that magnesium ribbon you coiled it up before? Okay. You guys remember that? You coiled it up and you put it in a little crucible. Okay. If I tell you one more time, you're losing the privilege. Okay. I know you sit there and you think I can't see it, but I can. I can see through Gary, right through Nick, and then I can't see through the iPad, but I can see it. But that magnesium comes in a coil, all right? And every year I order it. Sometimes I order it from the same manufacturer, sometimes I don't, but it doesn't matter. Each time you get that coil, there's production, I don't want to say inconsistencies, but there's production variation. Which means that when I get it, sometimes it's thinner, sometimes it's thicker, sometimes it's wider, and that affects how much a length of it weighs. You with me on that? So what I'll do tomorrow is I want you to have a certain mass, because a certain mass will produce a certain amount of gas. And I want something that's manageable in your thing. I don't want it to be too small, I don't want it to be too big. So what I'll do tomorrow is I'll get you a piece that weighs 0.03 grams, and the way that'll work is I'll say, cut this length and just assume that it's 0.03. And part of the reason for that is, like, whenever you use a measuring device, typically it's the best in the middle of its range. So for instance, if I got say, our wrestling scale, okay? I'm not gonna wanna measure tenths of a pound. I don't wanna measure something that just weighs tenths of a pound on that, because the middle of its range is more about 150, 200 pounds. And it's most precise in that area. The scales that we have go down to 100th of a gram, and I want you to weigh 300ths. Get what I'm saying? And so to weigh that accurately on that scale is not gonna be that easy. So what I'll do is I'll just weigh a big piece of it, and then I'll tell you how much a littler piece will weigh. So I'll give you more on that tomorrow. So I'll say tomorrow, cut this length of ribbon. And then you're gonna take that ribbon and you're gonna roll it up or bend it. I'll show you mine in a second. And you're gonna tie it to a piece of string or thread. And I'll show you that in a second. Then you're gonna fill a large beaker, like this beaker here. It says about 1 inch from the brim. I'd say more about 2/3 full, okay? I'd say if you're somebody like, say, I imagine maybe Matt, you probably got some big hands, okay? Reasonably, you're a big dude, right? Bigger than me, and probably bigger than my hands. Maybe Bo, you got some big hands. If you go put your hand into that bucket, you're gonna overflow it and you're just gonna make a little mess. So I'd say 2/3 full is better. Hey, let's see. Okay, so far 2 minor modifications. One, in step 1, I'll tell you length to cut, and here I'm saying fill it about 2/3 full, not an inch from the brim. You're going to pour 5 milliliters of HCl gas into the gas collection tube, and then add water on top of it. So see this tube right here? It's like a big test tube. It's like a big test tube. So here's the open end, here's the closed end. This is actually upside down now, and if you see the numbers are all upside down there. Okay, because it's made to catch gas as it goes up. So you're going to fill this with about 5 milliliters of acid from over there, and then you're going to top it off the rest of the way with water. Then you're going to take that little piece of magnesium that you tied onto a string, and you're going to lower that coil into the gas collection tube to a depth of about 5 centimeters. Then you're going to seal it by putting your thumb over the top of it, and you're going to flip it over and put it into the bucket of water. And I'll show you that in a second. And then you're just going to wait. And what's going to happen is the acid's going to kind of trickle down because it's more dense. It's eventually going to hit the metal that's down there. The metal's going to start to dissolve. You're going to start releasing hydrogen. You're going to catch hydrogen up here. The reaction goes like this. Magnesium reacts with 2 hydrochloric acids to make this dissolved salt and then the gas that we're collecting. That gas is going to push the water out of the tube. So you're just going to get the bubble accumulating. You're going to measure the volume that you produce, you're going to measure the temperature of the water, and you're going to measure the barometric pressure because you need volume, temperature, and pressure to figure out moles. Okay? And then we'll look at these calculations here in a second. I'll write all this stuff up on the board so you can actually see. So we'll come back to that in a second. Okay, so hopefully I don't lose my connection. Okay. So here's what's going on. Okay. So first of all, I'm going to come over here, and I've got magnesium in the thread right there. I've got some scissors to cut the magnesium, some scissors to cut the thread, and then there's a ruler there to measure the length that you need. Okay, and so you're going to get a piece of magnesium that I tell you the length. Okay. And then over here, you've got your hydrochloric acid that you're going to use, and I'll put some in there later. I gotta put it out tomorrow so it's fresh. Don't spill it, son. So I'm going to come and first. Here's my little piece of magnesium. Now, they said in the procedure it says roll it into a coil. It doesn't really matter the shape. The shape does not matter. What matters is that shape can fit in that opening. And so you see I did it so it would be small enough to fit in there. Okay. So you're going to tie a piece of thread to the piece of metal. Now I've got my gas collection tube here. Notice that the numbers are upside down. Okay, so this is upside down right now. And if I go to the bottom, you see I can still fill it up to 5 milliliters. I got a way to measure 5 milliliters right there. You see the 5? Okay. So I'm going to fill that up to 5 milliliters of acid from over at the bench there. I'm going to fill it up the rest of the way to the tippy top with water. And it's probably best just to use that to do the filling, because you're not gonna get this under a spigot real easy or under a faucet, okay? All right, and then when you're all set, can I have you hold this for a second? Okay, what you're gonna do then is this is gonna be all full, okay? And I'm gonna take my little piece of magnesium and I'm gonna submerge it to a depth of about 5 centimeters, which is again, not that terribly crucial, maybe something like that. And I don't know if you can see it kinda,
Yeah.
you can see it in there, okay? Now, when you put that in there, when you try and put that in there, what's gonna happen is some of the water is gonna get pushed out, right? And it might not wanna sink. So if it doesn't wanna sink, use your thermometer to kind of push it under the surface to break the surface tension. Then you wanna top it off again with water so you make sure that there's no air bubbles in there. And I'm right-handed, I'll go like this. So I have this, like that, okay? And if I try and flip it this way, it's not gonna work too good. But if I flip it this way, it's gonna work a lot better. So when I flip this, what's gonna happen is the acid's gonna start flowing down, not super fast, so you've got a lot of time. But the thing that I wanna make sure that's not clear in the picture that you saw on the procedure is that you gotta pin this to the bottom, because if you don't, the piece of metal falls out and all the gas goes up in the air. So I'm gonna flip this over like this, submerge my hand in here, my thumb is touching the bottom right now, I'm gonna take my other hand up here, and I'm gonna pinch it to the bottom. And then I can just kind of slide this and maneuver this, if I can grab that from you now. I'm gonna slide this and maneuver this, and the way that these little things work here is that you open them up like this. Okay, and so what I'm gonna end up with is this pin here.
When we're putting it on, it doesn't matter if it comes off the bottom.
It does, because if it comes off the bottom, then you're gonna, the little piece of metal may fall out. So once you pin it to the bottom, leave it pinned to the bottom. So everybody see I got that in there now? Okay? And so you're just gonna let this go until the reaction stops. So the reaction won't initially happen, but eventually it'll start going, you'll know when it's over too. I've got a thermometer here. That's so we can measure the temperature of the water, and that's an indirect measure of the temperature of the gas that's up here. So when you measure the gas up here, do you see how the numbers go? They get bigger as you go down, right? So if I'm above the number 5, I'm actually in the 4 range. Everybody get that? Okay. All right, so I'm going to get volume from here. I'm going to get temperature from here. I'm going to get barometric pressure from here, okay? Now this right here, this red thing comes down like this, and it makes a U, and then it goes back up. And that's where I'm gonna read the pressure. Now, when I checked the pressure this morning, that's in torrs or millimeters of mercury. It's reading 776. The real value right now is, I think, 772 at the airport. Now, we could be right around that pressure that's probably measurement for here in downtown Erie too. So what I gotta do is I'll calibrate this for tomorrow. I'll have to add a little liquid to it, just, yeah, it fluctuates from year to year. So you're gonna read your pressure off of here, okay? So now you got some data. Okay. I think that's what I'm gonna show you there. Okay. All right. So let's now look at what calculations you can share and what you can't share. What do you think? Do you think it would be better for me to put things that you can share in black and things you can't share in red?
Yeah, sure.
Okay. So make sure you keep track, because I want to screw this up. All right, so let's see. All right, so starting out, you can share 1. This is under data and analysis. Number 1, you can share the barometric pressure. And you're going to read that off the barometer over there. Now that's going to come off in torrs or millimeters of mercury. Remember, you got to convert that to ATM for your phonemics. So the conversion, you're on your own, right? But the data, the raw data, you can share. 2, and this is how it's written on your sheet. I'm just telling you what you can share and what you can't. The temperature of the H2O is equal to the temperature of the H2. And you can share that. Now that's going to come off in Celsius, but obviously you need to convert it to Kelvin, so do that on your own. All right. 3. pressure of the dry H2 is equal to atmospheric pressure minus the vapor pressure of water. Which will be, so we can say that's equal to this minus this equals this. Okay. So basically what I'm saying is if you take atmospheric pressure minus the vapor pressure, this will give you the pressure of dry H2. Okay. So in order to do this calculation, one, you need atmospheric pressure, which is barometric pressure in ATMs. That make sense? This is what the barometer said. You wanted an ATM, so atmospheric pressure is just barometric pressure in ATM. The vapor pressure of water, you got to get from me. Now, when you get the vapor pressure of water from me, you're going to come up and you're going to say, my temperature of my water was so many degrees Celsius. And I'm going to go to a table here, and I'm going to say, well, the vapor pressure of your water is this many millimeters of mercury. Got me? So I'm going to share that with you in millimeters of mercury, so I will give this to you. But what do you got to convert it to do this? Atmospheres. Okay? So again, I'll give you a piece of data, but you got to change it.
Do you want us to round? Like, because we're on a,
I want you to make the best measurement you can. You know, if it involves rounding, you can round. Mm-hmm. Okay, so you can share the volume of H2 generated. Now, when you measure the volume of H2 generated, what do you think these little units are on here? You saw how far apart these things are. What volume do you think that is? One of those units. It's a milliliter. But what do you need to be in to do your calculation? Liters. Okay, so you can share the milliliter, but you got to do the conversion on your own. Let's see. So 5 moles of H2 generated equals the moles of mg, because they're a 1-to-1 ratio in the formula, and that's going to be equal to PV divided by RT. So we can say this is going to be equal to the pressure value times the volume divided by the R and the T. So your pressure is going to be your adjusted pressure, and this is where everybody went wrong on the test. Okay, what a lot of you guys did on the test is you added the pressure of water to the total pressure that we got from here, when actually it should be subtracted out. You know what I'm saying? The pressure inside that tube is going to be due to two gases, H2 and water vapor. If I know the pressure of the water vapor, I can subtract that from barometric pressure, and that will give me the pressure of the dry H2.
Are we assuming that it's a 100% yield?
Yes. And actually, it's not a bad assumption in this one. It's actually not a bad assumption. So pressure is going to be your adjusted pressure. Volume is going to come from your volume. Turn that into liters. R is 0.08206. Temperature is going to come from your temperature, which you have to turn into Kelvin. And then you have to do a calculation here, which I'm kind of babying you with it. The mass of magnesium is going to be equal to moles of Mg times 24.3 grams per mole, which is its molar mass. So that's going to be equal to moles of magnesium times 24.3 grams per mole. And that's going to be your... And then last, 7 actual mass is actually going to be 0.03 grams. That's what I'm going to give you a length for. That length that I tell you to cut tomorrow, That's how much you can assume that it weighs, as long as you make a good cut. Okay? And then that'll be due on Friday. So you do the lab tomorrow, then you got a day to do it. If you have questions, you can ask me on Edmodo, send it directly to me, right? 'Cause it's a lab. Right? And so, points for this quarter. Well, and it'll probably be, I guess we'll make your lives good. You wanna make it 40?
Sure.
And help a lot of you out? Okay. Good to go? Everybody know? Does anybody wanna take a picture of that? Go right ahead.